Hi and welcome to my PlayHouse. And yeah, it's almost Christmas. Therefore the Christmas decorations in the background here. And I have a Christmas horror story for you. And it's all about networking. It has nothing to do with the ongoing Log4j security hole, but it has to do with something completely different. It all started a few years back. We had a network error. You know, when you make a loop in the network and they just go haywire and the switches kills themselves in traffic because something is connected wrong or somebody opened for something and then it was connected wrong. And that gave us about a 15 minutes downtime on the whole system. It wasn't the whole thing, but on major systems there was like 15 minutes where it was inaccessible, and the network department figured that out and they fixed it, and 15 minutes later it was kind of all good to go. So the management was called into upper management and told that this must never happen again and it's a disaster and blah 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 blah. Yeah, they had to do something. So they decided that we needed software-defined network. I'm not a network guy, but I believe that we were running Cisco Catalyst 6500-ish, like backbone switches, something. I have no idea. But now we were supposed to be running software-defined network. In Cisco world, that's called ACI. I forget what that stands for, but it's bloody expensive. And the part that I do know is that it's very much like the Ubiquiti that I use, where I can say that this port out here and the 3 switches out, it has to be a management port. And even though there's 3 switches behind it, as soon as I tell it that that's a management port, it will do all the configurations of the switches between there, and then this single port out there becomes a management switch. And yeah, it's also, this should be very good for micros cementing, like very small, like servers that can only see just exactly what they need to see. So it has some good things. The network department did not think so. They generally had more trust in the old system, but now management came and told them we need to run this. Probably because some good Cisco salespeople has been doing a good job there. Nevertheless, 2 of the best network people got tired of that. They left. And when I say 2 of the best network people, those are 2 of the best network people that can't be bought for money. My job is not where you go and work if you just want the money. Then we were supposed to get this ACI, and that meant that we need to change all the switches for this ACI thing. And the first shot is almost free. But afterwards it costs. So we got some switches for a very fair amount of money. That wasn't too bad at all. After that, the switches became very, very expensive. A normal set of 10G top of rack switches we usually paid about 50,000 Danish kroners for. That's probably, let's just say $8,000. $8,000, give or take. Top of rack switches, you get a set, 2 times 48 ports, 10G. Awesome. With these ACI switches, the price is now for 2 top of rack switches is now 250,000 Danish kroners, and that is considerably more. My extended brain says that that's about $37,900. So 5 times as much ish. Very expensive to get those switches, but nevertheless we were told that we were gonna go that route. We also were in the middle of building 2 new data centers. And these 2 data centers has been completed and has been ready-ish. Like they're not ready, they're still, the last little bits are always being worked on. But now that these switches were so expensive, putting a set of top of rack switches in every rack seemed kind of wasteful. Even for the management. The data center has 2 times 40 racks. That would be 80 sets of 250,000 Danish kroners, which comes to about 20 million Danish kroners, and that's just about $3 million for just the switches, top of rack switches in every rack. So it was decided that we needed to do that cheaper. You can kind of do a patching where you instead of a switch in the top of rack, you set patch panels, and then you patch the patch panels over to the switches. And this is where the real horror starts. This is the usual way to do this. You have a rack, you have a couple of top of rack switches. A couple because you need redundancy. These switches needs to be patched as well. And if you're running servers down here, production servers that is in 24/7 operation, you actually want to be able to take one of the switches out of production, patch it, and do the same thing with the other one. Then you can just switch switches while patching, firmware updating or something like that. So you have servers, and for normal thing you have at least 2 network cards so that you connect them one network to each of the switches, and the server's operating system has to be able to use 2 network connection and has the same IP number, and like teaming on that, and you do the same thing with the other server down here. So that's the very simple version. The normal thing is to use fiber optic cables today. Anything over 10 gigabits. I don't think there is copper for that, but this is what you can use when you're in a rack. This is a DOC cable. It goes in the SFP plus slot of the network card in your server, and it goes up to the switch. And this way you get a copper cable, so you save the hassle from going from electric to light and back to electric with the small delays that are there. But that's not the only hassle that you save, because those fiber optic connections, they are a hassle to work with. These fiber optic cables here, they are very delicate. This is one of the most delicate ones, because this one takes the 2 connections and put it into one cable. There's 2 strings inside of here, and then they bring that to the other side. But every cable has, in each end, they have 2 connections, one for transceiving and one for receiving, and in the other end it has the same thing. So there's like 4 possibilities for error here. If just one of these are dirty, you will have a bad signal. And it won't exactly tell you that the cable is dirty, it'll just tell you that there is no connection. Hassle. So that's the normal way to do it. Let me draw what my good workplace came up with. We'll reuse this. In this scenario it was switches. We're gonna change that. There. So it looks something like this. Instead of switches up here, we have patch panels. There is 2 patch panels, and each of these patch panels has room for 72 connections. So it's quite a lot actually. So a total of 144 connections, and those connections go over. Well, the top one is the A side, and the bottom one is the B side. There. So this one goes over here, and it goes into a patch rack in what we call the patch area. And the B side, all of those 72 connections goes down here to the B side. Let's pick the same one over here. So far so good. From this rack, when you connect the server, you connect it up into the patch rack, and this is often a normal VMware server has like 6 fiber optic connections. 2 of them are fiber channel and 4 of them are the network. I'm just making one line here, but actually there is 3 connections going this way and 3 connections going this way. Over on the other end, this is where the patching happens. From here there is patch panels, and those patch panels go over to the switches. Everything is actually patched up here. So each of the patch panels here are connected to a switch and fully patched. And we're missing one. We're gonna cheat, we're gonna make one. There. These are the very expensive switches over here, and they are fully patched to the patch panel. Same thing up here. So every time you connect the server, you have to go up to the patch panel, and then you need to connect equal amount of cables. If the server has 6 connections over here, you have to connect 3 connections on the A side, so that would be here, and we connect that to a switch. I'm just gonna make 1, and the idea is here that we fill up the switches, so every switch will be fully occupied, so there is no not used connections in the switches. So we do that on the A side, and we do the same thing on the B side. There, so far so good, right? And this cable is a regular other patch cable that you go over and you connect. So already we have 6 connections in the server, and we have 6 connections in the patch panel. Instead of just connecting the 6 cables over here, we now need to connect another 6 cables over here, and every connection has like 4 ends of it. So we have 24 fiber optic connection ends over here, and we have another 24 fiber optic connection ends over here. So we have doubled that, obviously. This looks very nice and very simple on the board here, but in reality it's a real hazard to work with. So this is a fiber optic cable inspection camera. So when you have a fiber optic connection like this one, which, well, each cable has 4 connections, so you test that. This one is a dirty one, and we can see this one failed. It has dirt on it and it's no good, and then we clean it, and then we use the next one, and this one is ever so slightly better. It might still, well, there's a big piece of something up here, and if I take this out and put it back in, that piece of dirt might have moved. It doesn't look like it moved, but there is no guarantee that that piece of gunk up here is not going to be right in front of the light if we don't do something. So we need to test all the 6 cables going into the server over here. We need to test all the 6 cables going into the patch panels over here. That's not the only thing, but it is the only thing when just hooking up a new server over here. These ACI switches that we have purchased over here, they can run 10 gigabit and they can run 25 gigabit. We have gotten all the switches with 25 gigabit. SFP 28, I believe they're called when we are talking 25 gigabit. Many of our servers that we are moving out into our data center runs 10 gigabit. If you have a 10 gigabit SFP plus over here, you cannot connect it to an SFP 28 over here running 25 gigabit. They are not backwards compatible. That means that this server, either you go out and you purchase a new network card for it and a new SFP, or you replace the SFP over here with a 10 gigabit one. This becomes very complicated because first you patch up the server, and then you patch up the patch panel, and then you know which SFP in the switch you have to go and replace. It sounds very, very easy. This is a simplification. We have 6 racks on the A side for this patching alone, and we have another 6 racks on the B side, so it's rather complicated to figure out that this server with this network card, well, on the A side and the B side we do the same thing. So port 10, let's say that it goes into port 10, and then over here that becomes port 27, and it would also be port 27, and then we go over here and we replace SFP in port number 27 on one of these switches. Rather a hassle. By the way, all of this, the racks here with all of these patch panels here and the patch panels in the rack, and these are fan out cables going from here and over to the switches. That was about 7 million Danish kroners, a little bit more than $1 million for that. Then we still have the switches over here. Granted, there are less of them. Also just very complex. So if we draw a server down here, this is a server, and we're just gonna take one network port. That has an SFP in it, SFP. It doesn't matter if it's 25 or if it's 10. So we put a cable in that, And we use LC connections for that. So we have an LC, that's these connections, that's an LC connection. As there's an LC connection in both ends, this is an LC-LC. So we take that and we go up to our patch panel. I'm gonna draw that a little bit simple. And we patch that in. There. And that's also LC. This patch panel is built out of modules. There are cassettes in it. Each cassette has room for 6 connections. So in a patch panel like this, there is like 3 rows. 1, 2, 3. Each of them has 24 connections. 24 connections. That makes 72 in all. That means that there's 4 cassettes in each of these rows, and these cassettes, they take the LC, I'm gonna draw it here, 1, 2, 3, 4, 5, 6 LC connections, and it brings that over to and that's called an MPO connection. That's a thicker fiber optic cable with more connections in it, and that means that there's 12 cassettes in one of these patch panels here. Total in a rack, there is like 24 of these cassettes, and each of them has this MPO cable, and that goes over to the rack. Connections in that MPO cable going over to the rack, where there's another cassette, which is a little bit different because this cassette, it has 12 connections in it. So that means that there's another cassette that also goes into that. So that takes 2 MPO connections in here, and then we get 12 LC connections out of that. Now we are about here. That's the connections that are sitting over here. And here we take an LC patch cable. That's the one that we connect in these connections here. And we patch that over into this system here, which is another 12 connection. I'm not gonna make 12, but there's 12 of those. So it's LC here, and it's MPO on the back, and there comes 2, I forget if it's 1 or if it's 2 MPO connections that comes out of that, but that runs over to the switches. So we're gonna make a switch here. But these cables are fan out cables. So instead of them needing a cassette, they go directly into 12 connections in the switches here. That's a weird fan out connection. So where this connection over here, if this is top of rack switches, there's 1 connection here, there's another connection here, that makes 2. I count 8 connections here. 1, 2, 3, 4, 5, 6, 7, 8 connections from the server and to the switch. That's a complexity increase of 4, where this has 2 and this has 8. So there's like 4 times as much that can go wrong here. This is a DAC cable, directly attached cable. So you can take that from the server and you can put it directly in the switch. You can't do that with a patch panel because the patch panel is meant for LC connections. So you can only use the patch panel for light. You can't do the electric stuff here. And the switches are far away, so these are only available up to 7 meters. After that, they need to be active cables and they become a lot more expensive. But this cable is about 13 euros for this cable. 3 meters, 13 euros. The fiber optic cable here, that is actually a little bit cheaper. It's about 10 euros for a 3 meter cable. So if it was just a matter of going from the server and up to the switch, the cable here would be cheaper. 13 euros, 10 euros. But this does not go directly into the server. It also needs a pair of SFPs. And these are 20 euros each for cheap ones. These are not actually cheap ones, but 20 euros each. So that means 10 euros for the cable, 20 euros each, that's 50 euros. Remind me how much this one was. It was 13 euros. So already this is very much more expensive. In our setup here, we also need a cable over here. So we can add a cable cost at about 10 euros. So we are at 60 euros for each cable that goes in. All of the rest over here, that has been configured. That was the thing that cost about $1 million. But for every cable from our servers to our patch, we need to add 60 euros per connection. That means that with 6 connections here, that's an added cost of 360 euros. So this is some horrible prices. A couple of switches like that, 48 ports, well, 250,000 Danish kroners. That comes out to a port price of 350 euros each port. The infrastructure, those 7 million Danish kroners used in the 2 data centers, giving us 144 ports in each rack. That comes out to 90 euros per port, the cable and the SFPs. I said cheap SFPs, the ones that we are actually using, I think they're about 300 Danish kroners each, so they are more like 40 euros each. So that comes out to close to 100 euros per connection. Let's just go with the 60. So in the setup that we are running right now, just to connect one connection, we have to add those 3 numbers. That's a total of 500 euros per connection. Crazy. Those 7 million Danish kroners used for the infrastructure, that would have bought us 28 sets of ACI switches. That means that to save those money back, there had to be 28 sets of switches lost in connections in all the other racks. Otherwise it's not going to be a good deal. On top of this spending, we have also like 12 Cisco ACI switches in each data center. So even though we have spent 7 million on the cabling infrastructure, we still need the switches. So we have like 12 in each data center, 12 plus 12 already. So if we had just gone ahead and spent the 20 million on 80 racks, X2 for the 2 switches in each rack, that would have given us 7,680 ports in total. The 28 sets of switches up here would have given us 2,688 ports that we could lose out of these ports without losing any money. That means instead of making this big cable mess, we could have left at least 1/3 of each switch not in use and still been good. And that on top of this data center more or less being a year delayed because of this patching infrastructure having to be purchased and installed. And yeah, you probably know how it is to get things from anywhere right now. So it has been months and months of delays, and then it has been bad products and returns and delays and even more. So yeah, horror story. So yeah, 500 euros per connection, and as a server has kind of like 6 connections, that's 3,000 euros for just hooking up one server. That's a bloody lot of money wasted on cables and connections. My Ubiquiti 10G switch with 16 connections, that was not even $500, I believe. It might actually have been 600 euros, but well, that was 16 connections. Horrible. And connecting the cables on these servers are just horrible. If we have to connect 4 servers, it usually takes a day for 2 men to make that work. So there is also the labor thing, and that's and moving to this software-defined networking, well, I can assure you that we have had downtime on more than 15 minutes, more than once. So yeah, it feels like a lot of wasted effort I'm so happy this was not my idea. I wouldn't like that. But never mind that, it's almost Christmas. And have you gotten me anything? Well, if you haven't, go over to my shop and see if there's anything to make me happy with by getting it off my hand. Very important to do the math before you start a major project like this. It seemed like a good idea at the start, but it has just turned out to be a nightmare. So thank you very much for watching my videos. Do subscribe to my channel so you can see me again, and have a really nice day. Bye bye.